So for chapter 4, we're in section 4.1, which is random experiments and counting rules and assigning probabilities. Okay. So what we have first of all is, what is a random experiment? A random experiment is one that it generates well-defined experimental outcomes, and probably of more importance, if you have to do it, on any repetition of the experiment, the outcome that occurs is completely by chance. So there's no way to, that you hear about people counting cards, or you hear about weighted dice or anything like that, where the outcome is skewed for a specific result. All of these are going to be random. Okay, so the probability of anything happening is not affected by anything on the outside. It's all completely generated by chance. So your sample space is simply going to be a list of all of the possible outcomes. So if you think about that, I know, like, I am recording, but I have my list on the side. So your sample space is going to be every possible outcome. So if you think about flipping a coin, then your sample space is either heads or tails. Those are your possible outcomes. Okay, if you think about a deck of cards, okay, then your possible outcomes are going to be every card that is in the deck. Okay, those are your elements of your sample space. So we've got a couple of basic rules that we need to look at. One of the rules is that the probability of anything occurring, okay, and I'm going to explain this notation in a second, is going to be between 0 and 1. Okay, so this is the probability of an event happening. Okay, and this little sub I, it's like a subscript. It's kind of like an exponent, but it's below. Okay, so the probability of anything happening is going to be between 0 and 1. Well, if you multiply this whole thing by 100 across all three places, it turns into 0%. Here's a percent, and this is 100%. Okay, so your probability, what we usually do is we report it in decimals, but remember, you can just multiply it by 100 and it gives you a percentage. So if I tell you that the probability of getting heads is 0.5, or the probability of getting tails is 0.5, okay, your heads and your tails are your sample space, and then the probability that you've assigned is 0.5 or 0.5, which if you multiply those by 100, you'll get 50%, 50%. Okay, so it's 50-50. The next thing is that everything in your experiment, all of the probabilities added together in your sample space, needs to add up to 100. So what we have is, and now I'm going to take away this little I right here, and I'm going to say the probability of event 1, okay, the probability of event 2, the probability of event 3, and we don't even have to have 3 of them, okay? So the probability of me eating chocolate is 100%. If you put chocolate in front of me, I will eat it. So I have this, and then I'm going to take this notation out, and I'm going to say the probability of however many elements are in my sample space. So in this case, what we would have with our heads and tails is we would only have these two probabilities right here. Okay, so the probability of event 1 is 0.5 plus the probability of event 2, which is 0.5. When you add those together, you get 1. So it's 100%. Everything is going to happen. Okay, so all of these add up to 1. That says equals 1. Sorry. And you may have the probability of something being 0. Okay, which is okay, but because 0 can be included as a probability. So whatever event we're talking about, this may be 0, this may be 0.72, this may be 0.18, and then so on, so on. As long as all of the probabilities add up to 1, then you're good to go. Okay, it can't be more than 1, it can't be less than 1, it has to be 1, which is equivalent to 100%. Okay, so then we're going to talk about a multiple step experiment. So if I have a multiple step experiment, and I'm going to give you an example of ice cream, okay? A multiple step experiment, what we're going to do is talk about the fundamental counting principle. Fundamental counting principle, which your book refers to as just a counting method, okay? Hang on, it's just the counting rule, okay? So your book refers to it as a counting rule. What it actually is a fundamental counting principle, and we can also make a tree diagram when we do this. Okay, so again, this is a multiple, that is not how you spell that, diagram. Okay, multiple step experiment. So you're looking at one experiment that has multiple steps within it. So let's go back to ice cream for a second. Okay, if I want to build an ice cream sundae, which is my experiment, what I need to do is choose a flavor. So good heavens, choose flavor. Okay, then we're going to choose a topping. And because I'm in charge, I'm going to tell you that you're restricted to one topping. Okay, one flavor, one topping, and one decoration. Okay, so that could be sprinkles or that could be whipped cream. So let's talk about this for a second. Let's say that you're going to have 3 flavors to choose from. So I'm going to have chocolate, vanilla, and strawberry. So I've got chocolate, vanilla, and strawberry. Okay. What toppings do I have? Well, I can have fudge, I can have caramel, or I can have, what else? Something else I can have? I can have butterscotch. Okay. So fudge, caramel, butterscotch. What decorations can I have? Or what's another floofy thing I can put on top? Okay, I can put whipped cream, which we'll use for W. Okay, and I can have nuts, so we'll say N. So those are my options. So it just so happened, because I'm in charge, that I decided that my experiment has several steps in it. Okay, I got to choose a flavor. Once that's done, I've got to choose a topping. Once that's done, I've got to choose a decoration that I want on top. And I've restricted you to saying you can only have one flavor of chocolate, vanilla, strawberry. You can have one topping of fudge, caramel, butterscotch. You can have one decoration between whipped cream and nuts. Okay, so this is my deal. This isn't set in stone. I can change it anytime I want to. All right, so what could I do? I can make a tree diagram. So what I'm going to start with is I'm going to say, all right, my goal is to make an S. I want a sundae. That's what I want. So the first thing I need to do is choose a flavor. So I've got 3 options for choosing a flavor. So there's my little tree diagram. And this is not going to be pretty because it's going to get crowded really fast. So once I choose chocolate, vanilla, or strawberry, that's phase 1. Okay, so I've got 3 options there. From there, I can choose 3 toppings. So if I choose chocolate, I can have fudge, caramel, or butterscotch. Okay, from here, I forgot what C was. I can have fudge, caramel, butterscotch. From here, these are not good options for flavors. Fudge, caramel, or butterscotch. Okay, so you just notice that I've now gone from 3 options to now I've got 3, 6, 9. Okay, well, now I can have a decoration. So on top of fudge, I told you this is going to get messy. I can have whipped cream or nuts. On top of caramel, I can have whipped cream or nuts. On top of butterscotch, whipped cream or nuts. And then I can keep doing this. Okay. And then this is whipped cream or nuts. And then this is whipped cream or nuts. So notice I'm being very, very, very methodical here. And I'm setting this thing up. So now how many options do I have here? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18 possible outcomes for my multiple step experiment. So that's just from 3 flavors, 3 toppings, 2 decorations. So there's got to be an easier way than making a tree diagram. So that's where the fundamental counting principle comes in. Your fundamental counting principle says with a multiple step experiment. Okay. And I keep repeating that because we've got a phase 1, phase 2, phase 3, or a step 1, step 2, step 3. Okay, what you can do is multiply the number of outcomes on each one. Okay, so what did we say? I just said that there was 18 possible outcomes. Well, how many flavors do I have? I've got 3 flavors. How many toppings do I have? I have 3 toppings. How many decorations do I have? I have 2 decorations. So 3 times 3 times 2 is 18. You have 18 possible outcomes. So your tree diagram gives you a picture of the fundamental counting principle. So that's a multiple step experiment. The other 2 that we're going to look at are combinations and permutations.